A reference type variable, therefore, stores a reference to an instance of an object rather than any actual data itself. Technically, all non-static object members, whether those be fields or methods, are available through this reference. And these objects are stored on the heap, not on the stack. We've also seen the basic instantiation, but look at the example at the bottom of the slide. Here again, we've got a variable p defined as type person. So to create an instance of the person class, person p equals new person, that's my instantiation statement. Then any public methods or accessible methods, in this case maybe a method or a field called name, I'm allowed to make a change to that element by going through that object variable or reference variable p. A single object on the heap can actually have more than one reference. And this is sort of interesting because what that means is that you could have different reference variables at different points in the application that all point to the same physical object. Therefore, if you were to manipulate the fields or the properties or call them methods of the object through one reference, then when you were to look at those values from another reference, you would see those modifications. So any change that's made to the instance will actually be visible by all other references. Take a look at the example here. In this case, we're creating a reference variable called p1, and we're doing an actual instantiation at this point. p1 equals new person. Then I create another reference variable, p2. p2 is assigned to the same reference as p1. So technically now, p1 is equal to p2, or in other words, those two references point to the same physical object. Now, if I were to change the name by going through p2, p2.name equals Steve, and then I were to change the name of p1, p1.name equals Mike, what's the result? In this case, p2.name would be equal to Mike. That's because the change that was made through p1 changed the data that was stored in the same reference or the same object that p2 is referencing as well. So anything that you do through any of these references is actually going to be visible through the other references. This can happen quite frequently, especially when you start passing in reference variable types as parameters and methods. In that case, you're actually passing in the references into the method. You may have two physical references that point to the same object, what you do inside your method, how you view it outside the method. Now, they can all really impact each other. So one of the important things to remember to do is when you're finished with your references, you need to put those away. You need to destroy those. In this example, I've taken the reference p2 and I've destroyed that reference by setting p2 equal to null. p2 equals null disassociates the reference variable p2 with the actual object. That means that p2 is no longer a live reference. This would be a null reference. p1 may still be active and the object may still be loaded. However, as soon as the p1 reference is discontinued as well, the object no longer has any references that point to it. It would be available for garbage collection.